Okay, this is site 5 on the Anity burn, and in this tutorial I'm going to be explaining to you the likely factors which are influencing the characteristics of the river at this location. Before we do that, let's just quickly review what's Bradshaw would expect to be happening at this location. Now that we're at the 5th location downstream, we would have expected the discharge to once again have increased. We'd expect the average rock size in our river channel to have decreased again. We'd have expected our rocks to have become more rounded at this location. And finally, we'd expect our river to continue to increase in its efficiency. We'd expect its hydraulic radius to be higher at this location. So let's just have a quick little think about what we're likely to see in our data once we've gathered it. Let's start with discharge. Now, at site 4, we will likely have seen a big increase in discharge because of the geological change and a number of other factors that I mentioned. We would expect this to continue at site 5. As a matter of fact, we might expect a very dramatic increase in discharge at the river at this location. And there's a number of significant factors happening at this particular location that's causing that. So why is the discharge increasing or likely to have increased so dramatically at site 5? Well, the first reason is the surrounding landscape is urban. So any water that is on this landscape or falls onto this landscape from the sky is either going to hit roofs, where it is then going to be channelized into guttering. It's then going to move down the downpipes. Just wait for that. And then when it gets to the bottom, it will go into a drain. Now that drain will lead under this road to the actual river channel itself over there. Likewise, if I just walk a little bit further down here, if the water falls on anywhere on this tarmac, it's going to, instead of infiltrating into the tarmac, which it cannot do, it's going to go into a drain, which I'm just walking towards in the distance. That you can see. So there is a drain, and that drain itself, which I'm just leading you towards, will have a pipe that goes under this verge here. So any water falling in this entire landscape, actually, whether it's on the building or on the road, goes into the drain, and then it comes out of a pipe in the side of the river, which is actually concealed by the vegetation growth on the riverbank here. So there is a pipe that comes out of the wall here. So the discharge is dramatically increasing at this location because the landscape itself cannot absorb any water because it's all urbanized, and therefore all of the water in this particular part of the drainage basin is getting very quickly channelized to the river, which will have caused its discharge to likely to have increased quite dramatically. Another reason for a big increase in the discharge is actually because the water is moving very fast in this location, and that's because the river has been straightened. You can see that the river is very straight here, and that is man-made. And the reason that the river has been artificially straightened, we can see that a wall has been built on both sides. So we've got a wall just here at my feet, and on the other side we've got a wall, and those two walls are artificially straightening the river, which means the river is traveling in a direct line and flowing much faster. Now, the reason for straightening the river is it allows the water to move through this landscape very quick. They're very keen in Scone, where we are located, to have this river and the water in this river to pass through the town quickly. By doing so, it reduces flooding, and that's why they've straightened it. When you straighten a river, the velocity starts traveling much faster, which we can see in the river, and therefore the water is clearing the town much quicker. And of course, if the velocity increases at this location, then the discharge will increase, because velocity is part of the discharge calculation. So there's a second reason. Another reason for the increasing velocity is they are doing a thing called dredging. And dredging is where they dig up material periodically from the base of the river. And you can see there's very little in the way of big material in the river here. And the reason diggers come in and excavate this channel is to make the channel deeper and clear away all the material that's building up. That therefore makes the river far more efficient, because you're removing rock from the bottom of the channel, allowing water to flow much freer, therefore travels faster, which increases the discharge. So these are a number of reasons that are increasing the discharge. Now, if we look at some of the other characteristics, what about the rock size? Well, the average rock size in the river, we can see there's very little in the way of very large rocks. and we can clearly see that. And the reason for that is that they are dredging the river at this location. So a lot of the bigger material is getting taken out every year by the local authority as they clear the channel. And the material we're seeing here is the material that's built up over the winter and has been deposited from upstream. And at some point later on this year, they'll come in and they will remove this material and once again deepen the channel, giving it a greater capacity. So we would expect the rock size to have reduced. The rock shape, well, we can clearly see there's a lot of very rounded, smooth material in this river channel. The rocks are all losing their angles, and we would therefore be expecting to find more sub-rounded and rounded rocks in our channel. That's largely because we're now quite far downstream, and therefore anything traveling in the river is getting quite significantly eroded through attrition at this location. So that's rock size and rock shape. Let's think about efficiency. Well, the efficiency of our river has increased a lot, and that is, we've already discussed the reasons for that. Two reasons why your efficiency data is likely to have shown a big increase, or I should say your hydraulic radius, is because we have a straightened river channel here, which is making the water flow much more efficiently through the channel. We also have a dredged river channel, which is creating a deeper, wider channel, which allows water to flow through it much quicker. It's difficult to imagine what this stream looks like in winter, but in winter, all of this vegetation on the side will be washed away, and this river will be full right up to the banks there. And the water will be flowing very fast and very efficiently downriver and through under the bridge there. So in this particular tutorial, I've looked at a range of factors that might influence your discharge, rock size, rock shape, and the hydraulic radius data. You now look to write them up. This site specifically is quite important to discuss because it's a critical site in judging the your data changes. There's some significant changes here, largely to do with the fact that we're in an urban area, and therefore your data is going to be showing some very different results than what you might expect according to Bradshaw's model.